Hey guys, welcome back. It's Coach Sharf. Still going over the 200-page packet. We are looking at page 14, and we're actually going to do page 15 as well in this video, and I'll explain why in a second. Page 14 only has a couple problems we're actually going to work out. Page 15 has a good handful, so I'm still going to try to get through as quick as possible so it's not a 30-minute video. So let's just go ahead and jump into it. All right, question number 4 talks about construction. So it is a standard, but construction it basically means using different tools like a compass, maybe a protractor, things like that to draw certain geometric figures. Again, we didn't really go into this at all this year. Might have shown a couple brief examples. So the answer to this one's going to be number 1. Okay, this one right here. What you would actually do is you would take the compass at point A and you would draw a circle with a certain radius, but the only part that matters is kind of this arc that's drawn. So you would set the compass out to a certain radius and draw the circle. You would do the same at point B. You would set the midpoint for the compass at point B and draw a circle. So the two circles would intersect at two spots, here and here. So then you would draw a line connecting those 2 points, which would happen to be perpendicular to AB. Okay? All right. 75. When a quadrilateral is reflected over the line y equals x, which geometric relationship is not preserved? Congruence, orientation, parallelism, or perpendicularity. All right, so I'm going to draw this one out for y'all so y'all can see an example, okay? So the only one y'all probably might be able to remember from that one is when we're reflecting over the line y equals x, anytime we do a reflection or a translation or a rotation, the new shape is congruent to the old one, okay? So with the translation, we might have moved it somewhere else on the coordinate plane. Rotation, we rotated it to another part of the coordinate plane, reflected it, we flipped it, but it's still congruent. It's still the same shape, all right? When we reflect something, when we flip it, it doesn't get bigger or smaller, right? Orientation means the way it faces. So it's we can actually kind of go back to one of the problems from the last page, all right, to talk about orientation. These are not orientated the same way, all right, because this line has a positive slope, this one has a negative slope. Let me see if I can find another graph with a shape that we've done that kind of shows that. Let me see if I can find one. All right, these two triangles. Okay, here we go. All right, it says those two triangles are congruent, but they're not orientated the same way. All right, this one's pointing up that way, that one's pointing over like that. So orientation means that they're not only are they congruent, the shape stayed the same, but they're still facing the same direction. Okay. With the parallelism and perpendicularity, I was talking about if any of the segments that make up the shape are parallel to each other, they're still parallel to each other, and any segments that are perpendicular are still as well. Well, we know if the shapes are congruent, then all that has to be true, right? Nothing changed. So any sides that were parallel to each other before we reflected it still have to be parallel to each other after we reflected it, right? So it's going to be orientation, okay? And I'm going to try to show y'all an example of that. So again, I kind of have the coordinate plane drawn down here, all right? So I'm going to try to do a shape to try to show y'all an example, okay? All right, so I'm going to do 1 at 2, 1 at 3, 1 at 4, 2, and 1 at 3, 3. All right. So I got this funky looking quadrilateral, right? All right, so when we reflected over the line y equals x, we've looked at that one previously, so it would be this relationship, all right? Any coordinate points I have when I reflected over that line, that's the dotted line that I drew. I would just flip the actual coordinates, okay? So let's see here. So if I have 2, 1, that would go to 1, 2. All right, it would go up here. 3, 1 would go to 1, 3. All right. Three, 3 would still actually be it. Let me make that 3, 2, because I just don't know if that's going to help me because I drew my line a little off. Let's put it at 3. Well, let's see if I can get that to work. I'll put it at 3, 2. Let's see if I can get that to work. Okay, kind of looks like a parallelogram now. So we're going to go to 2, 3. And then this is 4, 2. So we're going to go to 2, 4, right? All right. So there we go. I've kind of drawn it. Again, it's not going to look exact here. All right. But this one's kind of more horizontal pointing and this one's more vertical pointing, right? It's, if we kind of turn it sideways, again, my line's not completely accurate. If we had something more right down the middle, we could see that that's almost looks like a reflection, right? So when we're looking at head on, the orientation is different, all right? So that was number 2. Okay? All right, 76. Going back to the circle equation. You know, we've seen a lot of these by now, but just in case y'all need the reminder, let me pull up the formula sheet. All right. It says, what's the equation of a circle with center 7, negative 3, and radius of 4? So if we look at equation of a circle, there it is, x minus h squared plus y minus k squared equals r squared. So again, the h is the x coordinate of the center, and we have to have the opposite sign from whatever the regular coordinate is. K is the y coordinate of the center, we need the opposite sign. And on the right hand side, the r squared, we got to take the radius and square it. So I got 7, negative 3, and 4. So the coordinates for the center, I got to take the opposite sign, so I need negative 7 and positive 3, and then for the radius, I got to square 4 to get 16. So I need negative 7, positive 3, and 16, which is going to be answer choice 3, all right? Or again, C if you prefer doing A, B, C, D like I do, all right? 77 is another construction, okay? Also doing a perpendicular bisector, so it's kind of the same idea we had earlier about, again, it's just the individual arc. They didn't come around and make the whole circle continue this down here, but it's kind of the same idea. Okay, it says, which 2 sets of construction marks, label 1, 2, 3, and 4, are part of the construction of the perpendicular bisector line segment AB. So, I mean, again, it's basically like the same problem we just had. Yeah, if we kind of come back up here to A, if we look where these are, again, we kind of, instead of drawing the whole circle, you just kind of had, had it cut off where it's just kind of like that part, and then trying to cover it up with my thumb here, like that part down there where they didn't complete the whole circle. So drag the wrong thing down there on the side. So it's going to be 1 and 3. All right, answer choice 2. Okay. All right. So that's it for page 14. Wanted to do that a little quicker than I did, but we're on to page 15 now. All right. A straight edge and a compass, so it's another construction. Okay. Straight edge and a compass were used to create the construction below. Arc EF was drawn from point B. So again, we would put the midpoint of the compass. So if y'all remember what compass is, I don't have one here with me. It's an instrument where you have a point that we would place on, point B. It's actually a sharp thing to kind of hold it. You can almost pierce the paper with it to kind of help you out. And then it's got a little attachment where you can put a pencil in there, and then the point that's on B stays in place, and there's a thing you use to rotate it on top, and you rotate it around, and the pencil will rotate around. So that's the part it would do right there, okay? Arc EF was drawn from point B, and arcs with equal radii were drawn from E and F. So now, after they drew that arc from B, they put it on point E and drew what I'm guessing is actually, if you kind of look at it right here, the arc on the right there, the more vertical one. All right, and then point F would be that other little mini arc. All right. So it says which statement is false. So 3 are true, 1 is false. All right. The measure of arc ABD. So that is ABD. That is this angle. I said arc, excuse me. Angle ABD is equal to the measure of angle DBC. DBC right there. Okay. So it's saying that the two smaller angles are equal. Okay. You can kind of use this one. You can kind of do this one logically. Okay. So it might even help if you do some numbers there. Okay. So we'll say ABD is 30 and DBC is 30. All right. So they're both 30 degrees. All right. So let's kind of use those assumptions trying to see if all 4 of these are true. All right, well, now make number 1 true. Okay, number 2, 1/2 of ABC equals ABD. Okay, well, here's ABC. All right, ABC, that's the whole thing. All right, so we got to use the angle addition postulate. Again, going back toward the beginning of the year. If I add these 2 smaller angles that are, again, let me write on the screen here. That's 30. And that's 30. They got to add up to 60, right? So I know ABC equals 60. So I wrote it down, all right? So it says half of ABC is equal to ABD. ABC 60, what's half of that? 30. Is ABD 30? It is, all right? So if we use those numbers to be true for, and again, it would be anything. So if we use some different numbers, all right, let's say we use 40 and 40. Those are still equal. And then if I added 40 and 40 to get the whole thing out, it would be 80. Okay? So if I take half of 80, it still gives me 40. All right? 2 times DBC equals ABC. DBC is 30, multiply it by 2 would be 60. That is ABC. So that one appears to be true as well. Number 4, 2 times the measure of arc ABC equals CBD. So I multiply ABC times 2. So multiply ABC times 2 is 120 is equal to CBD, which is CBD, DBC are the same. So let's say multiply that by 2 is 120 be equal to this one. And 120 is obviously not equal to 30. So number 4 is the false statement here. Okay? All right, 79. The diagram of KLM below, measure of angle L is 70, measure of angle M is 50, and MK is extended through N. What is the measure of LKN? So it wants this angle, okay? And again, this one's pretty easy. Again, we didn't really talk about the exterior angle theorem a lot, but again, if we remember, all right, I've showed it to y'all, we've been doing this, okay? So all 3 angles here got added to 180, right? 70 and 50 is 120, so that has to be 60, right? So when we extend this out, this angle and this 60-degree angle, they form a linear pair because they form this line that goes across. So those have to add up to 180 as well, right? So 60 plus what? 120. Okay, so this outside angle is 120. But again, that's what brings us to those 2 add up to 180. All 3 of those add up to 180. 60 is the same regardless. So if we take that out, 70 plus 50 has to equal the angle that's out here. which is 120. So the other two angles have to equal this angle that's out there. So even if you don't remember the exterior angle theorem, as long as you remember that all three of these guys up to 180, and that makes a linear, so that's 60, that makes a linear pair. It has to be 120, which is answer choice 2. All right, pick up. I was about to say page 16. Gotta go back to the top of this page though. All right, page 80, or still on page 15, question 80. I'm sorry. Point M is the midpoint of AB. If the coordinates of A are -3, 6, and the coordinates of M are -5, 2, what are the coordinates of B? So this is still doing midpoint formula, but instead of giving the two endpoints, we got to find the midpoint. We're given one endpoint, the midpoint, we got to find the other one, okay? So you can kind of finagle the midpoint formulas to try to get this to work, or you can kind of draw it out. To me, kind of drawing it out makes it easier. All right, so I'm gonna do A right here, which is -3, 6. All right, I might have made that a little lower than I wanted to. Let me touch that up real quick. There we go. All right. 1, 2, 3, 4, 5, 6, -3, 6, okay? M is -5, 2. 4, 5, 6, 7, I'm getting 6, 7 seconds. All right, so M is -5, 2, all right? So, 1, 2, 3, 4, 5, 1, 2, okay? So, again, this is halfway. So, point B is going to be like down here somewhere, right? So if this is halfway, all right, we went down 1, 2, 3, 4 over 1, 2, right? So we went down 4, we went left 2. So all I got to do is do that again, all right? So 1, 2, 3, 4, and then over 1, 2. So that's point B. Connect that if you want to, but we're really just looking for where this point is. I didn't need to draw that one. Really just looking for where this point is, which is at 1, 2, 3, 4, 5, 6, 7, -7, 1, 2, -2, and that is answer choice 4. So that is our answer. All right. 81, volume. Again, last thing we did before we left. What is the volume in cubic centimeters of a cylinder that has a height of 15 centimeters and a diameter of 12 centimeters? Well, first thing we need is the volume of a cylinder. Pi r squared h. Okay? So pi needs the radius. Again, these usually tend to give you the diameter, making you do that one extra step. If the diameter is 12, what's the radius? Half of the diameter would be 6, right? So volume is pi r squared h, so it's going to be pi times 6 squared times 15. A little quick math in my head, I will punch in the calculator. 6 squared is 36 times 15 is 180, 540 pi. Which should be, well, actually, let me bat that up because I didn't look at the answer choices. We look at the answer choices, they're all in terms of pi, right? They don't actually multiply it times 3.14. So you can just leave the pi as is and just do 6 squared times 15 in your calculator, which I will show you. And get the lights out of the glare of the calculator. All right, clear. Alright, trying to look through the calculators. I'll do the 6 squared. Alright. Times 15. See, I got it up there. I'm going to hit equals 540. Alright, so it is 540 pi, which is answer choice 2. Alright, 82. The angles of a triangle ABC are in the ratio of 8 to 3 to 4. So, again, we didn't tackle a problem quite like this, but if y'all know anything about the ratios, so it's divided up into that many parts, all right? So we got to add those numbers up, which is 15. So there's 15 total parts that the angle is divided up to. So 15, you always think about it as like 15 little angles like that, right? So the first angle is 8 of those parts. So really, it'll probably be even skinnier than this, all right? So let's say it's something like that. So it's really, you really have 1, 2, 3 angles there, 4, 5, 6, 7, 8. No, that was really big. But so it's almost kind of like 8 angles in a row side by side like that. And when you take everything away except the outside, that's what you're left with, right? So it's kind of, you can almost think about it like that, but there's 15 total parts. I know y'all seen some of that before, and that's the ratio, right? So we got to figure out one part, all right? So we do 180 divided by 15, which I know is 12. Again, you can punch in your calculator, check, right? So one part is 12. So we're at a ratio of 8 to 3 to 4, all right? So if you want to double check and be sure, you can multiply all those by 12. So 8 times 12, which is 96. I'm about to show it, I'll show it in a second. 3 times 12, which is 36. And 4 times 12, which is 48. If you really want to add those all up to double check it, you can. It will be 180, I promise. The smallest one is 36 degrees, which is answer choice 3. All right. 83. For which polygon does the sum of the measures of the interior angles equal the sum of the measures of the exterior angles? All right, this is a very tricky problem, okay? So, again, we didn't talk about anything quite like this in this context, okay? There's we looked at a couple different formulas that you can do going about this. But I think the easiest thing to kind of show y'all is in terms of linear pairs, okay? So let's start with a triangle. Except what I'm going to do with this triangle is I'm going to draw every line past where it goes, all right? So here's my triangle, but every line extends past that, right? So, for example, again, let's just say it's an equilateral triangle, all right? Well, let's even say it's not to make it easier for ourselves, because equilateral triangle will be easy. Let's say it's not, all right? So let's say that this is a 45-degree angle, all right? So if this is a 45-degree angle, both this angle and this angle, right, this angle forms a line with 45 here. This angle forms this line with 45 going that way. Again, if you want to kind of turn it sideways as proof, you can do that. So what would I add to 45 to get 180? That would be 135, right? So again, you can either do 135 up there or on this side. It doesn't matter, okay? Let's say this angle is 50 degrees, okay? So same idea. I'm gonna have to kind of rotate this now a little bit, all right? So again, it'd be either this angle, or actually if we looked at it this way, it would be, oh, didn't turn it quite all the way. It would be this angle, all right? Because this angle formed this line, right? So either way, we're doing a linear pair there, so either one of those would be 130, okay? So if we add those, 45 and 90 is 95, so this angle has to be 75, okay? So again, 75 in this angle, form a line, or it would also be with this one. What adds to that would be 180, be 105, right? We add all that, it's 180, we know that. If we add everything outside here, would be 370. Okay. All right, 370. Okay, so let's look at a quadrilateral. Okay. I think the easiest thing here is going to be a square, but then I'll even show you with another quadrilateral. All right. So a square or a rectangle. Okay. But again, let's say everything goes past. All right. Well, what do we know about a square? All the angles are 90, right? So that's 90. Again, if you look at it, this angle forms this line, so that would also be 90. And again, this angle is outside of this square. Okay, that's what it means by exterior angle. This angle would also be 90 because it forms this line. All right, so you would have 90 and 90 either way you did it. All right, and it'd be the same thing all the way around. Again, you can use either this angle or this angle. 90, 90, 90, 90, 90, 90. All right. So we got 360 degrees inside, 90 added up on the outside is off this one, so 360. So those would be, okay. So it is going to be quadrilateral. Let's look at another one where it's not all like that. All right. Let's say we got a parallelogram. Okay. Didn't mean to extend that quite that far. Let me erase that because I need a little extra room. All right. So again, if we're extending it past, right? All right, so let's say this is 110, okay? So if we remember our rules about parallelograms, opposite angles are congruent, so that also has to be 110. Consecutive angles are supplementary, so I got 70 and 70, okay? Well, here's the thing about this, okay? If this is 110, it forms this angle on that side, that's 70. Okay, tab's 180. And again, if you look at these two 70s, you got two parallel lines and a transversal going. Those are alternate interior angles. All right. Went over that when we did that. Okay. Same thing kind of over here. This is 110. This has to be 70 on the outside. That's got to be 110. That's got to be 110. If I add up everything inside, that's 360. If I add up everything on the outside, that's also 360. All right. So it's got to be answer choice 3. All right. I believe that is it for page 15. All right, that is. So I'll cut this video. I'll do one just for page 16 by itself. We'll be caught up for the week of the 27th through the 1st. And by the time y'all probably see us tomorrow, I'll send out the message. We got one more week to go this week. We are going to end your work a week early to give you a chance next week to catch up. Anybody that's behind or still trying to turn in their work to get their grade up. We're not going to add any extra work next week just to give everybody a chance to kind of finish up so I can get grades in as quick as possible. All right. So I'm going to cut off this video and I'll see y'all at the video for page 16.